Welcome to Raos Academy. Today we are going to discuss winds and jet streams. Before going to discuss winds and jet streams, we are going to see few MCQs regarding previous topics. Two places at sea level have same temperature, but one has higher humidity, which has lower pressure. They are asking. Dry place, B humid place, C both same, D can't say. They are asking about two places and one place is having at same surface, both places having same temperature, but one place is having, for example, place A is having higher humidity, more moisture. Higher humidity means more moisture. Now this place B is having lesser humidity compared to place A. This is having less humidity, means less moisture. Less moisture means dry air. Dry air means dense air and it sinks. Sinking of air means what you will see? You will see high pressure, means place B is having high pressure and place A is having low pressure. Dry place, humid place, both same or cannot say. You can say with humidity and even temperature also you can say whether place is having high pressure or low pressure. More temperature means air rises, less temperature means dense air and air sinks. Here more humidity means it is having light air rises, there you will see low pressure. Dry air, it dense air it sinks and there you will see high pressure area. Answer is dry place. Consider the following statements. 1. Equatorial low pressure belts are also known as doldrums and subtropical high pressure belts are also known as horse latitudes. 2. Trade winds blow between subtropical high pressure belts and subpolar low pressure belts. 3. Prevailing westerlies blow between equatorial low pressure belt and subtropical high pressure belts. They are asking about pressure belts and even winds. Winds we are going to discuss next. Okay, this question afterwards we will discuss. Shifting of pressure belts. Today we are going to discuss shifting of pressure belts. We have seen different types of pressure belts: equatorial low, subtropical high pressure belt and again polar low pressure belt. Why we will see shifting of pressure belts? Because of differential heating. Because of differential heating we will see shifting of pressure belts. In reality, the location of this pressure belts is not permanent when you take pressure belts. For example, equatorial low pressure belt. Shifting happens between 0 to 5 degrees in northern hemisphere and southern hemisphere because of seasons, because of revolution around sun and varying seasons. For example, in winter during December, during winter season in northern hemisphere you will see low temperature or low insolation compared to southern hemisphere. Means the pressure belts shift southwards during January. In January during winter season, and in July or June time when we observe In northern hemisphere, summer season, during summer season what we will see? We will see shift towards north. Shift towards north. See, June, summer, actually normal position if you see, and in June, summer season, you will see northward shift, and in December you will see southward shift, because in southern hemisphere you will see summer season in December. Based on the heating, based on the insulation, pressure belts, they shift accordingly. One thing what you have to remember, January southward shift, June or July northward shift. Because of insulation difference. The thermal equator, commonly known as, what is thermal equator? ITCZ, known as the belt of highest temperature, also shift northwards and southwards of the equator during different seasons, that you have to remember. With the shifting of thermal equator northwards in summer and southwards in winter, there is also a slight shift in pressure belts also. Because of this thermal equator shifting, we are going to see shifting of pressure belts also towards north and south. Now, significance of pressure belts. Why pressure belts are very important for us in atmosphere or in weather condition or even climate change also. Pressure belts play a very important role, and significance of pressure belts can be asked in statement form. First, global wind circulation. The pressure belt drive the movement of air masses. From these pressure belts only we are going to see permanent winds, trade winds, under permanent winds we are going to see trade winds, westerlies, easterlies, all those things. Global wind circulation is dependent on pressure belts. Next, weather and climate regulation. If you don't have any interaction between high pressure and low pressure system, then how weather is formed? If you take polar low pressure and subtropical high pressure and polar high pressure, means differential heating. Because of that differential heating, pressure belts form. Because of pressure gradient force only, the wind starts moving. Because of that movement, what you will see different types of cyclones, temperate cyclones near polar front, tropical cyclones near equatorial low pressure and subtropical high pressure belts. So, weather and climate regulation. Next, ocean currents. Ocean currents. In ocean currents also, these pressure belts play a very important role. If you see, winds associated with pressure belts influence ocean currents, which in turn regulate. Under ocean currents, we are having warm ocean currents and cold ocean currents. Warm ocean currents and cold ocean currents. And in turn, these ocean currents help in heat transfer or heat distribution. If you don't have any heat distribution, equatorial zone, at equatorial zone you will see intense heating, at polar regions you will see intense cooling effect. Heat transfer or maintaining that heat distribution is very important. That heat distribution you will see by winds and ocean currents. That winds and ocean currents are done by these pressure belts. If you don't have difference in pressure systems, you don't see any wind movement or ocean currents movement. and impact on agriculture also. If you take pressure belts determine seasonal distribution of rainfall. If you take subtropical high pressure zone, there you will see dry winds, dry areas, and if you take equatorial low pressure zone, there you will see more rainfall, more convection currents, air rises, and you will see fast cloud formation or more cloud formation you will see, and those in turn influence crop production in those regions. Next, human and environmental impact. Human and environmental impact, if we can predict by using these pressure belts, we can predict extreme weather events like cyclones, droughts and monsoon. Now, next topic we are going to see planetary winds or permanent winds. We have three types of planetary winds: trade winds, westerlies and polar easterlies. One, trade winds. Two, easterlies. Three, polar easterlies. These trade winds are also known as tropical easterlies. Tropical easterlies. Why they are called permanent or planetary winds? Because direction of winds remain same throughout the year. Direction of winds remain same throughout the year. And with these planetary winds, we are going to link pressure belts and even global air circulation. We have seen, we have read all the three circles, right? Cells, Hadley cell, Ferrel cell and polar cell. We are going to interlink these previous pressure belts topic with global air circulation topic with these winds. Then only you can understand climatology clearly. First, we are going to start with trade winds. Trade winds are also known as tropical easterlies, blows from subtropical high from 30 degrees. For example, this is subtropical high pressure belt. We have seen subpolar low pressure and this is equatorial low pressure. This is polar high in northern hemisphere. Same you will see in southern hemisphere also. So, now we are going to discuss between these two pressure belts and we are going to discuss winds blowing between these two pressure belts, subtropical high pressure and equatorial low pressure. Blow from these trade winds blow from subtropical high from here to equatorial low, means here 0 degrees. From 30 degrees they blow like this. Now, when they are moving like this, because of Coriolis force in northern hemisphere, deflection is towards right side. Deflection is towards right side. When you take in southern hemisphere, deflection is towards left side. Deflection is towards left side. Means from northeast side, they are moving towards southwest. Or simply we can say they are moving from east to west. Easterlies means they move from east to west. That you have to remember. And westerlies from west to east. Direction: northeast trade winds in northern hemisphere, southeast trade winds in southern hemisphere. Northeast trade winds means from northeast they move towards southwest. Northeast towards southwest, that you have to remember. Warm, steady and reliable winds helped early navigation. That's why they are known as trade winds. What is the importance of these winds for India? After crossing equator, southeast trade winds deflect and they become southwest monsoon winds. In monsoon we are going to cover. Here Tropic of Cancer. Example India is there. And these southeast trade winds during monsoon season, they deflect and they become southwest. Southeast, they become southwest during Indian monsoon season. That you have to remember, crucial for our Indian agriculture. Next, westerlies. Westerlies blow from subtropical high to subpolar low. This you have to remember, subtropical, subpolar. Subtropical, subpolar. High to low. High to low. Always wind moves from high pressure to low pressure. That you have to remember here. Subtropical high pressure 30 degrees, subpolar low pressure, it is around 60 degrees. Now from winds moving from subtropical high pressure to subpolar low pressure in this direction. Now because of Coriolis force, winds deflect towards right side in northern hemisphere. In southern hemisphere, because of Coriolis force, they deflect towards left side. So, from here, from horse latitudes towards subpolar low pressure. Right side deflection, here you will see left side deflection. These are known as westerlies because they blow from west to east. West to east side. West to east. Because of strong in southern hemisphere because you don't have any frictional drag or frictional force or land mass is less. Because of that you will see strong westerlies in southern hemisphere, and we have different types of names for westerlies in southern hemisphere. During winter, because of they are strong during winter because they have greater temperature contrast. Subtropical high pressure is warm and subpolar low pressure cool. During winters, subpolar low pressure, they will become very cool because of this high temperature contrast. They are very fast and they are fast during winters. And we have different types of names in southern hemisphere. At 40 degrees, they are known as roaring 40s. At 50s, furious 50s. At 60 degrees, they are known as screaming 60s. Simply, UPSC, they can ask these terms and they can ask these are related to which planetary winds or which permanent winds. You can answer westerlies. Westerlies in southern hemisphere, that you have to remember because of less land. You will see less obstruction. West to east. Directions are very important. Subtropical high pressure to subpolar low pressure. And even pressure belts also very important. Now, polar easterlies. Polar easterlies, they blow from polar high to subpolar low pressure. Same right side deflection in northern hemisphere. In southern hemisphere, left side deflection. In southern hemisphere, they are blowing from east to west. That's why they are known as easterlies. Easterlies, east to west. This you have to remember. Polar high pressure belt to subpolar low pressure belt. Cold and dry winds. And here you will see mid westerlies at polar plains. Here you will see temperate cyclone formation. Here. Temperate cyclone formation, here you will see at subpolar low pressure belt, and meeting point of these two winds you will see polar front, and that at that polar front we are going to learn temperate cyclone in next class. Okay. First, trade winds 0 to 30 degrees. From 30 degrees they blow towards 0 degrees, means subtropical high pressure to equatorial low pressure. This you have to remember. Other name tropical easterlies. Tropical easterlies. See, from subtropical direction is very important. Northeast to southwest in northern hemisphere. In southern hemisphere, southeast to northwest. Northern hemisphere northeast to southwest. In southern hemisphere southeast to northwest. Overall from east to west they blow. Very important. Next, westerlies. West to east. Subtropical high pressure to subpolar low pressure. From 30 degrees they move towards 60 degrees. And in southern hemisphere we have different names because land obstruction is less. Those names you have to remember. Next, polar easterlies. Polar easterlies from 90 degrees. Polar high pressure to subpolar low pressure. Here directions very important, and from which belt they are blowing, that is also very important, because in statements they can ask. For example, polar easterlies they blow from subpolar low pressure to polar high pressure. Under polar easterlies we are having two different pressure belts. They mention same pressure belts but they change the direction. They give polar, subpolar to polar high pressure. There you have to remember the direction. These are the UPSC traps, because for example in westerlies also they can give some subtropical high pressure, not subpolar low pressure to subtropical high pressure. Wind blows from high pressure to low pressure, that you have to remember, and you have to remember different types of pressure belts, degrees and direction, northeast, southwest or west to east, east to west. All those are very important. Next, local winds. Local winds, they are the small scale winds that blow over a limited area for a short duration due to local differences in temperature and pressure. Due to local differences in temperature and pressure, we have different types of local winds. We have 4 types of local winds. First one, land and sea breeze. Next, valley breeze and mountain breeze. Next, hot local winds and cold local winds. Land breeze and sea breeze. Very important. You have to know what is land breeze and what is sea breeze. Whenever we are talking about any wind, from where it starts, the name has given from the based on the starting point. For example, wind is moving from sea to land, means sea breeze. When wind is moving from land to sea, means land breeze. Based on the starting point, we are going to name the wind. For example, if you take trade winds, tropical easterlies, we are saying tropical easterlies. Starting point, east side. From east, they are moving towards west. If you take westerlies also, from west, they are moving towards east. Like this also, you can remember wind direction. Wind directions are very confusing, and these are the main UPSC traps in your Indian climatology topic. Under climatology topic, pressure belts and wind systems. Confusing, but how you have to remember with concept. First, wind moves from high pressure to low pressure. Based on the starting point, from which direction they are moving, from where, west or east, based on that they are named. For example, if I take land breeze, means here these local winds, they move from land to sea. First thing here, sea breeze means sea to land, sea to land. Clear? Important? Very important. And why land and sea breeze? Because of differential heating. What happens? Land heats very fast and cools very fast. During daytime, what happens? During daytime, land is more warm compared to sea. Because of this, here you will see low pressure, and on sea you will see high pressure. Compared to land, sea is somewhat cooler, and because of this differential heating, what you will see? We will see different pressure zones. Here high pressure, here low pressure. The wind moves from sea to land. The wind moves from sea to land. This is known as sea breeze. This is known as sea breeze. During daytime, the land heats up very fast. Because of that, here on land you will see low pressure, and on sea you will see high pressure. Wind moves from high pressure to low pressure, means wind moves from sea to land, means sea breeze. Morning time, what you will see? Sea breeze. That you have to remember. During night time, what happens? Land cools very fast compared to sea. Here on land you will see high pressure, and on sea you will see low pressure. Because of this, the wind moves from land to sea. That is known as land breeze. We call it as land breeze. Very important. Land breeze is during night time, because over land you will see high pressure and over sea you will see low pressure. Sea breeze is during daytime because of differential heating. See, reasons also you must know. Most of the times concept based questions, UPSC asks concept based questions based on the reason. If I say differential heating, because of differential heating wind moves from here to here, yes, that is true. For example, in statement 1, if I say during daytime the wind at coastal areas move from sea to land. In second statement, if I give the reason, because of differential heating, there you will see differential pressure belts, not belts, pressure areas. Because of that differential pressure areas, we will see the wind movement. During daytime and nighttime, differential wind movement we are going to see. Means statement 2 explains statement 1. Land to sea during night time, sea to land during daytime. That you have to remember. Valley breeze, from valley, wind moves from valley to mountain. Mountain breeze, wind moves from mountain slopes towards valley. This valley breeze at during daytime, what happens? Warm air rises up the slope Warm air rises up the slope. From valley towards mountain, they rises. Warm air. That is known as valley breeze or anabatic wind. Anabatic wind means up. During daytime, what happens? Sorry, during night time. At night, cold dense air sinks into valley. Sinks into valley. This is known as katabatic wind. Katabatic effect. Katabatic means downwards. Valley breeze, anabatic upwards. Valley breeze, day, mountain, night. Here wind rises and during night time wind, air sinks. Air sinking you will see in mountain breeze. These two differences you have to remember. You have to remember. Next, hot local winds. Hot local winds, very warm, dry winds that blow over specific regions due to intense surface heating. Due to intense surface heating and pressure gradients. Because of pressure gradients and intense surface heating, we are going to see hot local winds. They usually originate over hot deserts, dry interiors. Dry interiors, when you take interior, you will see interior of the continents, you will see extreme climates because land heats very fast and cools very fast. In summers, you will see more heat and in winters, you will see more cold. Blow towards relatively low pressure areas. Few examples. First, Lu. Important. These names are also very important. Lu, hot dry wind blowing over North India and Pakistan. High temperatures west to east direction. West to east direction. Lu, you have to remember our India, North India and Pakistan. Fawn, warm dry wind on the leeward side of Alps. Leeward side of Alps. Caused by air rising and cooling on the windward side. It means snow, that you have to remember. Alps. Chinook, hot dry wind on eastern slopes of Rocky Mountains, US. On eastern slopes of Rocky Mountains. Chinook means Rocky Mountains. In maths of following also they can ask. Lu, India, North India and Pakistan. Fawn, Alps, Chinook, Rocky, or they are also known as, Chinook is also known as snow eater, means snow quickly. Sirocco, hot, dry, dusty wind from Sahara Desert. SS you have to remember. Sahara Desert. Sirocco, Sahara Desert. Crosses Mediterranean Sea and cools slightly. After crossing Mediterranean Sea, you will see cooling effect. Harmattan, hot, dry, dusty winds from Sahara Desert. These you have to remember. Both Sirocco and Harmattan, Sahara Desert, blows over Northwest Africa. Northwest Africa. It improves air quality. It is also known as the doctor. Direction you have to remember. Sirocco towards Mediterranean Sea, Harmattan towards north west side. Even comes in also hot local winds. Here Lu, you can see Lu, Fawn and Chinook. Rockies are there. Santa Ana also towards Rockies. Zonda, Atacama Desert. Important names means they can give these names and they can ask whether they are hot, cold local winds or cold local winds, or they can give match the following also, like hot local winds and place towards from where it will blow. Cold local winds, mistral, cold dry wind blowing down the Alps in France. Fawn also Alps, but hot local winds, mistral, Alps, but cold local winds. That you have to remember. Next, Bora, cold dry high speed wind from mountains in Adriatic Sea region. Adriatic Sea, strong and forceful. Next, blizzard. Blizzard, violent wind with freezing temperatures and blowing snow. Here, Bora, Mistral, blizzard. With map, you have to remember hot local winds and cold local winds. Simply saying blizzard means there, Chinook means Rocky Mountains, Fawn means Alps, not like that. If you see map, with map, you can easily remember. Here, Mistral, Alps, Fawn, Alps, but Mistral is cold, Fawn is hot local winds. Now, cold local winds, Mistral, Bora, Karaburan, Buran, Karaburan means with names also. Based on the culture, based on the location, we have different types of names. If you take blizzard like western name, and busters in Australia, Pampero in South America. Like this, you have to remember cold local winds and hot local winds, different types of cold and hot local winds. Okay. In next class, we are going to see jet streams and air masses along with few MCQs. First, these two MCQs we are going to cover first. Okay, consider the following. We have done only one MCQ. Next, equatorial low pressure belts are also known as doldrums, and subtropical high pressure belts are also known as horse latitudes. Trade winds blow between subtropical high pressure belts and subpolar low pressure belts. Prevailing westerlies blow between equatorial low pressure belts and subtropical high pressure belts. They are asking about trade winds, westerlies and equatorial low pressure and high pressure. Yes. See the statements and which of the following statements are correct, they are asking. A, 1 only, B, 1 and 2, C, 1 and 3, D, 1, 2 and 3. If you take a first example, first statement, statement 1 is correct. Equatorial low pressure belts are also known as doldrums. Subtropical high pressure belts, yes, horse latitudes. We have seen the story of horse latitudes also. They used to throw horse. Next, trade winds. Trade winds, tropical easterlies. Tropical easterlies means they blow from subtropical high pressure and towards equatorial low. So, this is wrong. Westerlies from subtropical high pressure to subpolar low pressure means they have interchanged the belts. Only one only is the correct answer. Next question. Which of the following statements is true regarding the seasonal shifting of pressure belts? 1. Pressure belts are constant throughout the year and so is the climate associated with them. 2. Pressure belts migrate according to the shift of the sun, thereby affecting climate in different seasons. Pressure belts are reversed in different seasons. So the answer is 2 only. Here you will see migration, not constant, not reverse, slight shift. We are going to see in, you don't see any reversal because from equatorial low pressure they does not become subtropical high pressure. You don't see any reversal, but slight shifting of pressure belts we are going to see because of shift of the sun, apparent movement of the sun. Okay. Consider the following statements about the Hadley cell. Air rises near the equator. 2. Air sinks near 30 degrees latitude. 3. It operates between 30 and 60 degree latitudes. So the answer is 1 and 2. Hadley cell from 0 to 30 degrees in northern hemisphere and southern hemisphere. Not 30 and 60, from 0 to 30. Okay. Consider the following statements regarding ferrule cell. It operates between 30 and 60 degrees latitudes. It is a thermally direct cell. It is responsible for the westerlies. They are asking whether it is a thermally direct cell. We have two types, thermally and dynamic. Thermally indirect, dynamic or thermally indirect. It is not because of temperature difference, or it is because of dynamic. It is because of sinking arm of Hadley cell. Because of Hadley cell, we will see subtropical high pressure. If you take subtropical high pressure area, there you will see warm temperatures. Even though warm temperature is there, you will see high pressure because of dynamic reason, because of thermally indirect cell, because of sinking arm of Hadley cell. So 2 is wrong. 1 and 3 is the answer. 1 and 3 is the answer. Yes, from ferrule, in ferrule cell only you will see westerlies. Okay. Tomorrow we are going to discuss jet streams and air masses.